Hello again, everybody. This is Tom from EveryStepCalculus.com, EveryStepPhysics.com. Another partial fraction decomposition problem. Puzzle. I call them puzzles because calculus is 1,000 or more, many thousands of puzzles that they want you to solve, all useless for anything practical. But anyways, we have to do this for our homework and passing tests or whatever. This will never be on a test because it's just too extremely difficult. You need 5 integrals to solve this problem, but I like to program it because then it's done for life, forever. I can always do this, and you can too if you buy my programs and download them into your TI-89 calculator. And so let's do this. Index 8 to get to my menu. And you scroll down in the menu. First menu comes up to partial fraction, and click on that, and we're into the program. We're going to enter this function here, you would, on your calculator. I've already programmed it into here so that keep the simulator honest and not screwing up on me. But you have to press second alpha to put letters in this entry line here in my programs. Letters being x cubed and whatever the problem is. So normally you'd press alpha, not second alpha, but just alpha, and you'd put in, let's see, 8 times x cubed, for instance. There's 8 times x cubed, but I'm going to press enter here now and go into the actual problem that I programmed so to save time, etc. And here it is, okay. But remember, you have to press alpha before you put these characters in here. And I show you that. Notice partial fraction is that you can factor the denominator, and this can be factored, whether you could do that without a calculator by your own. We could all do that if we're in algebra and studying it and right into it, but probably not right now. So I factor it for you. Here it is, x squared plus 4 to the second power. And then we go into the actual program. When it says B down here, it's search program or programs. Is a program takes some time to load it. Once it's loaded, like now, then it comes up quickly. And so I show you how to set up the partial fractions. And for the left side of the equation, you're going to multiply it times the denominator. We're trying to get rid of the denominator on both sides, so we multiply times the denominator. And then we set up the right side. And we multiply that times x squared plus 4 because this is on the right side of the equation for the partial fractions. You need that. I show you that. So you write this x squared plus 4 to the second power times ax plus b. You write this on your paper exactly as you see it, and you'll get an A in this problem, okay? We're going to eliminate the denominator, ax plus b. So we do that because this can be broken down into 2 times, and when we multiply the times the denominator, we eliminate the denominator and come up with this here, ax plus b times x squared plus 4. Same thing with the cx plus d. Cx plus d times x squared plus squared, and of course that completely eliminates, so you end up with cx plus d. Think of the guy who invented this stuff or thought about it. He had a lot of time to waste, I guess, It wasn't Newton. Newton didn't come close to solving these kind of problems or being into this kind of problems, Newton and Leibniz were working on exponents, that's what they were working on, and then of course it developed into calculus. So keep writing this exactly down as you see it. So now we got 8x cubed plus 3x squared plus 7 is equal to ax plus b times x squared plus 4 plus cx plus d. Now we have to multiply this using the FOIL method, ax plus b times x squared plus 4. Right here is what I tell you to do it. And then it comes up to ax cubed plus 4ax plus bx squared plus 4b cx plus d. Isn't this fun? Total waste of time, but you know, that's why I program it. I don't have to ever touch it again. I don't have to ever think about it again. It's all here. We combine like terms. Turns out to be ax cubed plus bx squared plus 4a plus cx 4b plus d. Okay. Now we take the coefficients of the numerator left and then match it with the right side. So we have 8x cubed here is equal to ax cubed. So then a has to equal 8. All right. Same thing with 3x squared equals bx squared. So b is equal to 3. And we have 0x is equal to, because there's no x value in this problem here, right? So 4a plus c times x is equal to 0. And then 0 is, and then we put in the value for a, which is 8. And then it turns out to be minus 32 when we do the algebraic computation of it, okay? And here's 7, the last one, here's the 7 part, times 4b plus d. We know what b is, so we add that in there, which turns to be 12. And then we take d, and so we move the 12 over the other side. With the minus side, we go minus x. And then we we have d with becomes a minus 5. So the original partials are x plus b here. Okay, here they are, what we did way before. And now we put in the values we just found here, 8x plus 3 minus 32x minus 5. So we have all over x squared plus 4, x squared plus 4 squared. And then we set up the integrals. Here's the integral, 8x, and then 3 minus 32 times this, minus 5 times that, right? So we set up the integrals now, and we integrate each one of them. Here's the first, 8x over x squared plus dx, okay? And we take the constant out always when we're integrating, and we sub those in and do the u substitution, write all this stuff, and you notice the page would be more than one full notebook page to do this problem. Constant out of the integral for the second one, and that turns out to be an integration rule that we solve that one with. And then turns out to be 3/2 times tangent of arctangent x over 2 plus c. Third integral would be here, u substitution again because we got an x in the numerator, so we can find u equals x squared plus a, and then we have x dx, okay? So it turns out to be minus 16 integral of 1 over u squared du. We substitute in, integrate it, and then back substitute. Turns out to be 16 divided by x squared plus 4 plus c. Fourth integral, minus 5 x squared plus 4 squared dx. Constant out of the integral. Apply a reduction formula. We didn't know anything about that. I didn't know it either. It took me quite a while to program this stuff, find out about what's going on with it. doesn't come to mind right away, you know. Here's the formula. Look at the formula. Of course, you could memorize that, can't you? Oh yeah, you know all this stuff. And then we do our computations for A and N, and then we sub those in. We simplify more. Then we integrate the integral that we came up with. And so we have the reduction. This is the reduction formula problem answer for this, what we started out with, minus 12 times the denominator, you know. And turns out to be this right here, okay? 2 answers. So this original integral, like here, here's the answer starts out to be 4 times log of x squared plus 4, and these different ones, but we have to combine the arctangents together. Here's 2 arctangents, so we combine that together. And then the final answer is this right here, plus c. Wasn't that fun? Go to my site, buy my programs, and pass calc, and it's simple as that. I'll help you every step away. I'll give you all the information I have for my programs and for calculus itself. And you'll certainly pass, you know, with it, that's for sure. I don't even know if they use these calculators anymore in college, which ones they're using. So you have to be concerned about that. But even you can always buy these on eBay, you know, and you'll get more money for it when you sell them with my programs in it. So anyways, good luck with your classes, and I'm all for you passing, okay? I'll help you all I can. Have a good one.